Okay, so good morning, and today this is our lecture number 6, and I have divided this lecture in two parts. One is 6A. I will take approximately half an hour, and then 6B, and that is also another half an hour. So what we are going to learn in this lecture, objectives and outcomes. So what is objective? So in last lecture we have seen various fabrication steps of CMOS as well as NMOS, and we have seen some masks are used to carry out that particular process steps. So how to draw those masks? So that is called as layout. So today we are going to describe various Lambda based layout design rules used for successful fabrication of integrated circuit. Yes, there are some rules. You have to follow those rules. And what are those rules that we are going to understand? So we are going to learn about Lambda based rules. So what are Lambda? So there are another types of rules, but just we will understand what is that micron rules. Okay. Then to draw layout of MOSFET and CMOS inverter using Lambda based rules. So this is also one of the objectives. Then what you will know, students will be able to draw layout of MOSFET and CMOS inverter using Lambda based rules. Okay, so these are outcomes, objectives and outcomes of the lecture. So rules. For each and every rules, means for example, when we were offline, so there was a rule that our college starts at 9 a.m. and after it goes up to 5 p.m. depending on your practicals and other things. So the rule is that you have to come at 9 o'clock. So why?
Yes.
Because if you come at 9 o'clock, definitely lecture will start at 9 o'clock. So whatever teacher is teaching, that all of you will receive. Means basically you will that is successful thing if you follow the rules. But it also means that if you come at 9:10, so is anything is going to happen? Nothing will happen. Means still you are going to hear the lecture, you are going to attend the lecture. But only thing is that difference that you will miss something.
Yes,
so you will not get utilization fully. So to increase the probability of successful integrated circuits with higher yield. So that is the need. Is what it increases the probability of success if you follow the rules. Okay. Then other need is layout rules describe the separation between two lines. Because see, we are fabricating billions of transistors, millions of transistors. We say we follow that, right? So what it means basically, it means that when we follow the billions of transistors, when we fabricate billions of transistors, two transistors are close to each other. And if you just check drain of one transistor and other drain of other transistors, they may be close to each other. So what should be the distance between drain contact of one transistor and other transistors? Basically, it is separation between two transistors, two lines, two gates. So that describes. Then minimum length and width of area. So there is active area mass. What should be its minimum length? What should be its minimum width? And what should be the minimum feature size? Is how much minimum dimension we can print on the mask or we can draw on the mask. Yeah. So this is the need of design rules. Basically, main need is you can increase the chances of probability of success. That's the main need to follow the rules. Then there are types of rules. What is meant by types of rules? So there are two types of rule. One is called as micron rule, as name micron indicates. So in which layout constraints such as minimum feature size minimum allowable separations are stated in terms of absolute dimensions in micrometer. What it means, if I, for example, if I draw two lines here, if I take two lines, for example, here, okay, so I can say that this is one polysilicon line, whatever you see here, and there is another polysilicon line. Okay, these are two polysilicon lines. So what it tells us, so what is the distance between these two? Minimum distance. If you are drawing polysilicon here, if you are drawing polysilicon here, this is gate of one transistor, this is gate of another transistor. Okay, so what should be the minimum distance? So that distance is specified in terms of microns. Suppose it is 1 micrometer. So they may specify like this. It is 1 micron. So absolute values, it specifies absolute values. Okay, so this distance is specified by absolute value. You can see here. So that rule is called as micron rules. It is specified in terms of absolute dimensions in micrometer. Now, what is lambda rules? So lambda rules, so these are called as micron rules, but we are not using micron rules. We use lambda rules. Lambda rules in which specify the layout constraint. So these are the layout constraints. So what should be the minimum width? What should be the minimum distance? In terms of single parameter, lambda, in terms of single parameter. So, and this allows linear proportional scaling of all geometrical constants. Means, for example, instead of this 1 micrometer, so here we just specify by lambda. We specify by lambda. Okay. Lambda is a single quantity. This might be 1 lambda, 2 lambda, 3 lambda, like that. So instead of 1 micrometer, so that's why these, if you change the value of lambda, then its value also gets changed. Okay.
Yes, sir.
So that's the difference between what I say, that is the difference between micron rules and lambda rules. So lambda rules in which layout constraints are specified in terms of single parameter, that is lambda, and thus allow linear scaling or linear and proportional scaling of all geometrical constraints. So therefore, lambda rules are scalable. We can scale. If we change value of lambda, it is scale. But in micron rules, since that value is specified by absolute number, like 1 micrometer, 0.5 micrometer. So if you want to move from one technology to another technology, then micron rules are not scalable. But in case of lambda rule, it is specified in terms of lambda. So change the lambda value. So that constraints will automatically
easily can be changed.
Yeah, easily changes. Okay, so there are two types. So let us understand now only lambda rules. Okay.
Yes, sir.
Okay, so first constraint of lambda rule is active area mask. You can see here, these are active area masks. You might have seen active area mask while fabricating our NMOS transistor,
Yes, sir.
as well as PMOS transistor. Okay, so there is rule R1. So this R1 stands for one rule and R2 stands for second rule. So what it means, minimum active area width. Now this is active area, you can see here. This is entire active area. This is another active area. So what should be the minimum width? Minimum width has to be 3 lambda. Okay, this is one rule. Minimum width of active area has to be 3 lambda. And what should be the separation between two active areas?
So 3 lambda.
3 lambda. Yes, for example, if I draw one more active area, if I draw one more active area, just to show you here, like this. Okay, this is active area, right? So can you tell me what should be the minimum width of this? Yahan se yahan tak, what should be the minimum width? So if I
sir,
specify here,
ये 3
minimum width,
lambda. हाँ, 3 lambda.
what should be the 3 lambda?
3
Yes, you got it.
lambda.
You got
Yes,
it
sir.
that its width should be,
And width should be 3 lambda, and spacing should be also 3
so it should
lambda.
be 3 lambda here, right?
Yes, sir.
It should be 3 lambda, right?
Yes, sir.
It should be 3 lambda. And this separation should be also 3 lambda. So these are 2 rules basically. Okay. These
Yes.
are 2 rules. One is separation. This is separation.
Yes, yes, spacing.
So these are the 2 rules, right?
Yes.
Now we'll move to another rule and we'll check what is the another rule is. Polysilicon. So this is polysilicon area. Polysilicon area, you might have seen, it is used to create gate of the MOSFET. You have seen that polysilicon
Yes,
mask,
yes.
gate
Yes.
mask,
Yeah, gate mask. Yes.
pink color or red color.
Yeah, yeah.
So
Yes,
it is basically used to create gate.
silicon.
So this is like a metal. It's a conductive plate.
Conductor.
Right?
Yeah. Yes.
So this is R3 rule, and this is R4 rule. What R3 rule says? R3 rule says us that, tells us that minimum width of the polysilicon area or gate mask has to be 2 lambda. Yes. And R4, again, it is a separation between 2 gates. You can say that one gate of one MOSFET will come here, another gate MOSFET will come here. So it has to be minimum. Isse zyada raha, no problem. But minimum has to be 2 lambda. Okay. So this is basically polysilicon rule. पहले active का देखा, अभी polysilicon का. Let us see third rule. Polysilicon R5. यहाँ पे mention किया what is R5, what is R6, what is R5. अभी we know that this is active area, right? Green whatever you see is active area, and this gate mask or polysilicon mask is actually coming on active area, right? Then only this becomes one part of this becomes source and other part becomes drain. Then there is a rule. What is that R5 rule? How much has to be extension? There has to be extension of polysilicon over active area. So this is active area and this is extension. If you align these two masks together, so R5, so that R5 has to be 2 lambda. See, extension of R5, extension of polysilicon has to be 2 lambda, right? Now similarly, separation, minimum poly active edge spacing. So this is poly spacing. If you see, this is polysilicon and this is edge and this is active area edge. So this is the spacing between polysilicon edge and active area space, and poly is outside active area. Remember, poly is outside active area. So this has to be 1 lambda. Okay, so this is R5 and this is R6. Now this is R7. So R7 rule is here. R7 tells us that minimum poly active edge spacing, but poly inside active area. Now this is poly is inside active area. This is poly edge, whatever you see. This is poly edge, and this is active edge. So this has to be 3 lambda. Okay, this has to be 3 lambda. So remember, this is also poly edge. This is also this is poly edge. This is active area edge. But this distance has to be 1 lambda because poly is outside active area. But here polysilicon mask or layout is inside active area. So therefore R7 tells us it has to be 3 lambda.
3 lambda.
Yes. Now metal rules, because we use metal also. Yes, you know, we use metal. So what should be the minimum distance and what should be the minimum width of metal? So metal is generally we show by color blue. So R8 is minimum active area and its width has to be 3 lambda, as it is mentioned here. It is 3 lambda or 8. And what should be the minimum spacing? Minimum spacing has to be again 3 lambda, that is R9. That is rule R9. Right. So let us move to next rule. Okay, contact rules, because we have to take contact, right? We are taking contact to polysilicon, that is gate contact. We take contact to active area. So what are those rules? So R10 is poly contact size. So here it is R10. So this is contact mass. So its size has to be 2 lambda by 2 lambda. Polysilicon contact size has to be 2 lambda by 2 lambda, because contact is like a polygon. You can say that it's a square approximately. And its size has to be 2 lambda and 2 lambda. This is R10. Now R11, you can take 2 contacts nearby. So what should be the minimum spacing? So if this is one contact, okay, and this is another contact, you can see here, this is one contact, this is another contact, and spacing has to be 2 lambda. That is your R11. So here I have mentioned it is R11. Now what is R12? Minimum poly contact to poly edge spacing. So what it means? Minimum poly contact to poly edge spacing, that is R12. So you can come here. This is R12. This is poly edge. You can see here polysilicon edge, and this is contact edge, right? So what should be the distance?
Yes.
Distance has to be 1 lambda. Now can you tell me that this is again contact edge? Yes, and this is poly edge. So what should be the distance from this point? Just see where I am pointing. This point to this point. Kitna hona chahiye? If I say what should be the minimum distance?
2 lambda.
Huh?
No, 1 lambda.
1 lambda, because
lambda.
this is poly edge and
poly
this is
edge.
contact edge.
Yes. Okay.
Right?
1 lambda. Yes.
Okay, so this is R12. Now what is R13? Because when we make a metal contact, so on that we put metal. So whatever you see here, that is metal. So that's why color is different. So this is metal edge and this is contact edge, R13. This R13, you can concentrate here, R13, 1 lambda. This is R13. Metal edge to contact edge. So, or I can draw it separately and I will tell you. So what is that? This one. Okay. So here is the facility. So 1 minute, I will just first I will take polysilicon. So I have taken polysilicon and I want to make the contact. So contact has to be black. I will tell you, contact has to be black. Okay, contact has to be black. Okay, this is contact. So this is contact. Now I have to put metal on this contact, right? I have to put the metal on the contact.
Yes, sir.
So when you put metal on the contact, so what it says, so if this is metal, okay, again contact has gone, so I will draw the contact here. So this is contact. So this rule R13 is, what is the distance between, basically distance between this metal edge and contact edge. Okay, what is the distance between metal edge and contact edge? And that has to be
1 lambda.
1 lambda. Okay.
Yes.
So it's like that. Okay. So that is R13. Now what is R14? R14 is active poly contact. So this is poly contact. And this is active edge spacing. So this is active area and it is spacing. So this has to be 3 lambda. Means if I am taking contact here and this is poly edge, so this has to be 3 lambda. So in this way, this particular slide is showing you how many rules? 14 rules, right? 14 rules. R10 to R14 means total 5 rules. Up till now we have seen 14 rules. So let us go with next rule. Again, contact rules. Now here I am showing contacts to active area. So earlier slide was polysilicon contacts. I have concentrated on polysilicon contact, but we take contact to active area also. So R15, again contact size, this is R15 rule here. You can check. And contact size has to be 2 lambda by 2 lambda. Okay, R15 rule, 2 lambda by 2 lambda. Then minimum spacing on active area, active contact spacing on same. So this is one active contact. This is another. Again, this has to be 2 lambda. That is R16. Here it is mentioned R16. Minimum has to be 2 lambda. R17. Again, active edge spacing. This is active contact edge spacing to metal spacing. Okay, so that is this is R17. Active edge spacing to contact spacing. Again, R17, 1 lambda. And active contact to metal edge spacing. So this is active contact and this is metal because we put metal. So R18 has to be 1 lambda. Okay. So in this way,
Yes,
when you draw a layout of MOSFET or layout of circuit, you have to follow all these rules. Okay, now contact rules. So R19, we have seen R19 because you know that this is active area. Okay, and this is polysilicon gate, right? This is forming the gate. And we take here contact. This might be source contact or drain contact. So this is contact edge and this is polysilicon edge. So what should be the minimum spacing? That spacing has to be 3 lambda. So R19 is minimum active contact to poly edge spacing has to be 3 lambda. And then if these contacts are on different active regions, here is one active region, here is one active region. So this is one contact, this is another contact on different active areas. This is contact edge, this is another contact edge, and this distance has to be 6 lambda. That is called as R20. So in this way, we have seen 20 rules up till now. So this you have to remember. Now, this is illustration of some typical MOSIS layout design rules. This is just illustration. So they have mentioned that instead of green, they have shown this is active area with this. So this is active area. This is polysilicon, whatever you see here. This is polysilicon. This is contact. So whatever you see here, these R15, R10, these are the contacts. And this is metal. Okay, this is metal. So in this way, a typical layout, we don't know what is there, but we will start with our layout with MOSFET and we will check. Now, how to determine minimum size of the transistor? Okay, how to determine? So let us start. So first, see, I want to put the contact here. So contact size is how much minimum? 2 lambda by 2 lambda, right?
2 lambda, 2 lambda. Yes,
so
sir.
this is just vertical dimensions. Width we will just calculate first. So this is 2 lambda, right? So यहाँ से यहाँ तक कितना? How much? 2 lambda.
Yes, sir. 2 lambda.
From this point to this point, how much it has to be?
1 lambda.
Contact edge to active edge, how much? 1 lambda.
1 lambda.
So, and this is how much? यहाँ से यहाँ तक
1 lambda.
1 lambda. So how much vertical direction? What should be the minimum width of the active area?
1 lambda plus 2.
Is 3 lambda. अगर
Three.
if you 4 lambda, 4 lambda,
4 for 2 and 1 and 1.
then only you can fit the contact. Okay.
Yes.
Although minimum you can draw 3 lambda, but if you want to put the contact, then you have to put 4 lambda. Right. Now let us calculate from this point to this point. Means ऐसा कितना हो गया 4 lambda. अभी लेंथ कितना एक्टिव एरिया का देते हैं. So tell me, this is active edge and contact edge. How much it has to be? 1 lambda.
1 lambda. Either 1 or either 2
This
lambda.
is 2, 3 lambda. And यहाँ से यहाँ तक 3 lambda होना चाहिए, right?
3 हाँ.
तो कितना हो गया 3 plus 3 6 lambda हो गया यहाँ.
6
Plus
6
ये
lambda.
2 lambda, 8
2
lambda.
lambda.
8 lambda
6, 7, 8.
3 lambda
Plus 3 lambda.
11 lambda plus 2 lambda
11 plus 2 lambda.
कितना हो गया
13
and plus 1
13
lambda
plus 1. 13 plus 1 14.
So 14 by 4
14
lambda is
14
area required for minimum transistor, so that you can put the gate, you can put contact and everything according to lambda rule, right? So in this way you can calculate minimum size of the transistor required. Now layout rules for N well and P well, so that we will see. There is another this one. So we will now move to lecture number 6B, right? So up till now we have seen metal rules, we have seen polysilicon rules, contact rules, contact to polysilicon, contact to active region, separation, everything we have seen. We will see the layout rules for well, N well, P well, क्या rules होते हैं, because CMOS fabrication में rules important. Now, what is the objective? To teach various layout rules for N well or P well. अभी तक well के लिए rules नहीं देखा हमने. Then to teach how to draw layout of MOSFET, CMOS inverter, NAND gate, NOR gate using lambda based rules. Okay. Then you will be able to apply layout design rules to draw layout of MOSFET, CMOS inverter, NAND gate, and NOR gate. So let us start. So you know that this is well, N well we have created. In N well, this is P active area. This is P active area. You know that.
Yes, sir.
And P active area. So these are the rules basically. ये कितना overlap होना चाहिए? What should be the overlap of active area or minimum overlap of P plus active area? Or what should be the minimum separation of N well with N plus active area? And what should be the separation of two active areas on difference? These are the rules, so that we will see. Okay, now these are wells. Okay, now it says that if well is at 2 wells are there, then separation has to be 6 lambda if this well and this well are at same potential. But if wells are at different potential, then that separation has to be 8 lambda. Then minimum size or width or length of the well, either N well or P well, has to be 10 lambda. Okay, so these are N well design rules. Minimum lambda कितना होना, area कितना होना चाहिए? 10 lambda by 10 lambda. Separation at different potential has to be 6 lambda.
Same potential 8, na?
Same potential 6 lambda and different potential 8 lambda.
Okay.
Now we have to put the contacts, right? So what are those contacts rules? So B1 is this. What should be the minimum? This one contact. B1 is 3 lambda, and there has to be separation of 3 lambda, right? Then B2 minimum spacing. B2, where is B2? B2 is here. Minimum spacing has to be 3 lambda. B3 N well overlap of P plus, means this is your P active area,
Okay.
and this is overlap, so that has to be 5 lambda. Then B4 rule. So what is B4? B4 is here. N well overlap of N plus. If I am taking N plus contact, because we take N plus contact, substrate contact, so that has to be 3 lambda. यहाँ से लेकिन P है तो how much it has to be 3 lambda, 5 lambda. Then B5, what is B5? This is N plus area. So outside N well, N plus area, active area has to be 5 lambda apart. So there has to be this much distance. And B6, if there is P plus active area, then B6, it has to be only 3 lambda. So these are the rules. So you need to understand and you need to apply to draw layout of various circuits. So let us start with layout of MOSFET. Okay. So how will start layout? Because active area is important. So what should be the minimum? अगर मुझे lambda rule लगाने का है तो what should be the minimum? 3 lambda and 3 lambda.
3 lambda.
Then I am using gate mass. So what should be the width of gate mass? It has to be 3 lambda. लेकिन contact यहाँ पे लगाने का है तो this area is I have made bigger. So we will find out it time. Then this is contact mass. What should be the minimum size? 2 lambda, 2 lambda, 2 lambda, 2 lambda. Then what should be the separation here? It has to be 2 lambda, like that.
2 lambda.
This is gate contact. Gate contact. Then metal. So metal should cover that contact. It should cover. It should cover. From each side there has to be 1 lambda, 1 lambda, 1 lambda. So therefore metal, you can say that this metal should be minimum size should be 2 lambda by 2 lambda. No, it is 2 lambda and 1 lambda, 4 lambda by 4 lambda. So metal contact has to be 4 lambda by 4 lambda. Then only you can put that. हाँ, अभी देख लो. Minimum dimensions are specified here. So this is 2 lambda contact. This has to be 2 lambda by 2 lambda. Then metal edge spacing and contact edge spacing has to be lambda. Right. Now this is active poly edge and active edge. This has to be lambda. Now this is substrate contact. So this has to be 4 lambda. This metal has to be 4 lambda by 4. क्योंकि यहाँ से lambda. This is 2 lambda. This has to be 4 lambda. And what should be the spacing? Spacing has to be 3 lambda. Contact edge spacing and active edge 3 lambda, right? Now this is inside extension of polysilicon. This has to be 2 lambda. Right? Extension है तो 2 lambda होना चाहिए. And how much this is poly active area contact to poly edge spacing has to be 3 lambda. So in this way, you need to specify all the dimensions when you draw layout of MOSFET. So this is layout of MOSFET. This is source or drain. This is source or drain. This is substrate contact, and this is gate contact. Okay. Because this is active area mask, then gate mask, then this is contact mask black wala, and whatever is shown that is metal mask. So all these masks are required. 4 masks are required for fabrication of either NMOS or PMOS. Now this is CMOS inverter. CMOS inverter में पहले N well mask. This is N well. Then these are 2 active areas, right? These are 2 active areas. These are 2 active areas here. These are 2 active areas. This is N active area. This is P active area. Then this is gate mask. You can see this is gate mask. We have drawn. After gate mask, then we have P plus mask, but that is not shown here. Then these are contact masks. These are contact masks. These are contact masks. This is substrate contact. And you have to specify dimensions everywhere, minimum dimension. Right? So this is drain, this is drain. It is connected together and output is taken. This is gate of NMOS, gate of PMOS, and input is applied here. This is VDD, and at the bottom what you see here is your VDD. Okay. Now what I will show you actually how to draw layout of MOSFET. Okay. Mhm. Okay, can you see this? Hello.
Yes, sir.
Huh.
Yes,
So
sir.
what I will do, I will first I will take active area mass. Okay, I will change its color also. Hmm? What color I have to choose? I have to choose green, right? So this is active area mass, right?
Okay. Yes, sir.
Then I will use gate mask, polysilicon color. So there has to be extension, right?
Blue.
And I will choose color polysilicon, either red or pink, right?
Okay.
So I will make this as transparent so that you can see the overlap. Oh, okay. So this is overlap. Okay. Then unit contact. You can put here contact. So you can put here contact, but contact has to be black.
White.
It is shown by black. Okay. So you too can
Yes, sir.
try this layout. Then where you need contact here also for gate.
Black.
Gate contact is taken back side. Okay. Then this is basically, and sometimes what happens, this is not sufficient. So that's why you need to increase this much area here only. So that's, then you need to specify this is 2 lambda by 2 lambda. This much is minimum lambda. This has to be minimum lambda. So this becomes 4 lambda. This has to be 3 lambda. This has to be 2 lambda.
2 lambda.
Again, this is 3 lambda.
Again 3
This is
lambda and
2
then
lambda,
1
3
lambda.
lambda like that. This is lambda. This is lambda.
Okay.
Then what is remaining? Remaining is metal.
That will be 4 lambda.
I will make it transparent.
4 lambda. 4 lambda.
Okay, so this is metal. This is 1 lambda, 1 lambda. It has to be there, right? So here also I can take this, right? Right? And this is your polysilicon. In this way, you can draw a layout of this one. Okay, I want to draw a layout of inverter. Again, you know the process. So I will use just new slide here. I will remove everything here. Okay. So first is N well. So this is my N well.
So 1 and
But what should be the color? Color has to be yellowish dark, that you might have gone through it.
yes, sir.
Something like this. More color, I can go to more colors. Okay, I can choose from this point itself. Okay. So this is my N well.
Same.
Then I need 2 active areas. One is P active area and another is
And
N active area. So this is active area for PMOS. So PMOS का generally बड़ा होता है, अनयेलोइश से दिखाते हैं हम, तो इसको थोड़ा सा बड़ा करता हूँ. Okay. Then I need active area for NMOS. So I will take it here and I will just change its color so that it will Then what I need gate mask, right? So gate mask, I will draw it here like this. I will change the color, don't worry. It's a polysilicon. Okay. I can use, because here also it is used like this, right? And I can use again to make contact here like this.
It's in pink.
Okay. So I will make this also transparent so that okay. Then what you have to do? You have to make the contacts. So where you will make the contact? Contact is here.
Side, over there, and two on the end.
So this is contact. This is contact here, right? Then again contact here. And contact here, and you have to take the contact here also. That is in. Now metal you have to put. So metal means you need to connect these two contacts together. Yeah. I will make this transparent so that you can see that.
Nice.
Okay. Then what I have to do? Again, I have to take contact to this. Okay, then what I have to do? I have to make this as a ground line.
Ground from there to there.
This is a ground.
Yes.
And in the same way, at the top also, what I have to do? This is contact here. And this is my VDD, this is my ground, and here also I have to make a contact. This is input. Okay. This is input, and this is output. Okay, so this layout and whatever that layout you have shown, now everywhere you have to put the dimensions. कहाँ पे 2 lambda होना चाहिए, कहाँ पे 3 lambda होना चाहिए. That is called as layout of CMOS inverter using lambda rules. Okay. So you got it?
Yes, sir.
Yeah. So this is any doubt?
No, sir.
Okay. Then can we stop here?
Yes, sir. Yes.
So you see, I have uploaded all lectures,
yes.
slides as well as recordings also I have uploaded.
Yes.
I have uploaded 2 quizzes for lecture 1 as well as for prerequisite. So you just try to solve it.
Okay.
Okay, that will help you
sir.
for IA1, IA2.
Okay.
Okay.
Okay, sir.
Then we will stop. Huh?
Okay, sir. Thank you.
Okay. Good day.